Hi, everybody, and I hope you're ready for another week of learning about weather. This week, we're going to watch a couple videos, take care of a few of our notes, and we're going to culminate the week with learning the differences between when it rains, when it sleets, when it does freezing rain, and when it snows. The work from now on is pass or fail. So just get the work done and learn what you can and you'll be fine. So I hope you find this interesting. I'm going to try to pick some things that I think are interesting. Um, you should have your notes J and K out, and you should have read this sheet already from that I posted, understanding air pressure. Um, Even if you didn't do that, though, look through these and fill in your notes as you can. So there's this note page, plus there's the little bit underneath that you will need to have read. So air pressure, this is all about air pressure. So how have we described weather so far? 3 words, beginning with P, T, and H. So the P stands for precipitation, right? Rain, things like that. The T, temperature. And the H, of course, is humidity. So that's how we've described all of weather so far. But there really is one thing we still need to explain, and that is air pressure. So what is air pressure? Well, who's dove down into the swimming pool or in a lake, and the further down you go, what do you notice? If you go down really deep, your ears start hurting, right? Why do they hurt? Well, that's pressure. It's the weight of all that water pushing on your head, and it just pushes in your inner ear, and you feel this pressure. So you have to equalize that pressure. Be careful by covering your nose and kind of blowing back the same way. I mean, the opposite direction. So you got pressure going in your ear this way, and you're going to increase the pressure. And once it's equal, then you don't notice it so much. Well, so it's that weight of the water. The further down you go, the more weight there is above you, and you feel more pressure, and that hurts. Well, we're not in water all the time, but we're always in the atmosphere, and there's miles and miles, 500 kilometers of atmosphere above us. And while the density of the atmosphere is not as much as the density of water, that is matter, and it does weigh something. So all of that atmosphere on top of us creates what we call air pressure. So what is air pressure? Well, it's the weight of all the air that's on top of you. So why aren't we crushed under so much air pressure? It's actually a lot of pressure. I think it's 15 pounds per every square inch. There's different units. But again, like your ear, as long as the pressure is equal on all sides, you don't really notice it. So the air pressure is exerted in all directions. So how do we measure air pressure? It balances out. So we measure air pressure with a barometer. And so this is not what a barometer looked like, but this is how a barometer works. And now they make electronic ones, but the traditional barometers were filled with mercury. This is mercury. And then this is open to the atmosphere. And then this actually there's no air in here. There's a vacuum right there. So what happens if the air pressure, so the air pressure is pushing down here, and it's pushing the mercury up here, and now it's at equilibrium. It's not moving anymore. But what happens if the air pressure increases? Well, if the air pressure increases, it's going to make this mercury move up more. And since there's no air right here, there's no air to compress to stop it. And so that mercury will be able to move on up. So mercury in the tube goes up, and it's this arrow right here that tells you, now this arrow has moved to up here. That tells you what the air pressure is. So there's different units for air pressure, and the one that the book talked about was millibars, and 1,113.2 millibars was exactly the pressure at sea level, average pressure at sea level. And now, so that's what you would read up there. So let's put it all in the big picture here now. So what does that look like to you? That should look like, or should remind you of those Hadley cells that we talked about earlier, air moving up and then moving out and then moving back down. That's exactly what it is. So air moving down, what happens when air is moving down? Well, remember, there's the weight of air above you, and it's always pushing down on you. And imagine, added to that weight, you have air moving down. Is that going to make the air pressure greater or less? And it's going to make it higher. So the weight of the air plus the movement of the air down, that's going to make high pressure. So that's what a high pressure is. Air moving down makes air pressure higher. Well, what about when air is moving up, like it is right there? So you've got the weight of the air on you, but that air is also slowly moving up. Well, you would imagine that's going to take a little bit of that pressure off, and you'd be right. That means that's a low pressure. So you get a low pressure wherever air is moving up. So what's wind? Because you don't really notice when air is falling on top of you or air is moving up. That's very slow, and you're not going to feel that. And I don't think anyone's ever felt wind going up or down. That just doesn't happen. What you do notice is wind always goes from side to side. So we say that's the horizontal movement of air. So wind is the horizontal movement of air. So what causes it? Well, you can see here, if this air is moving down, when it hits the ground, it can't keep on going into the ground. It's going to split off into two directions. And that's wind when it's going horizontally. In which direction is it going to go? Well, it's going to go from wherever it came from the high pressure, and it's going to get sucked back up where that low pressure is. So creating that convection cell. So air always moves from, the differences in air pressure cause the air to move. Sorry, that's blocked off, but I'll read it. Differences in air pressure cause air to move, and that's what we call wind. And it always moves from high pressure to low pressure. That's pretty much it. So what we're going to do now is there are these questions. So you look at this diagram, and there's all these questions. And on my web page, this isn't a live link for you, but on this web page, you're going to click on that knowledge check. As you scroll, you're going to see that same diagram, and you're just going to choose to see if you understand all this. So which arrows show air moving down? So choose however many arrows you think it's right. Could be one or could be two. And then just keep on answering all these questions. As soon as you answer those questions, when you hit submit, you'll find out which ones you were right or wrong, and then we'll go over the answers on the next video. That's it. Take that knowledge check. That's how I know that you've done this video. And starting today, these actually count for credit, so please get this done. If you have any questions, of course, talk to me during my office hours at 2 o'clock today.